Hi there, welcome back to the channel. In this video I'm going to show you my Bluetooth switch, which is operated by the Magic Eye tube on a tube radio. In the recent video that I did on the Bluetooth boards for adding Bluetooth to a tube radio, I mentioned that I was creating a switch which allowed this module to be switched off when Bluetooth was not in use in the tube radio. This is to cut off any noise when you've actually got radio reception coming through. Well, I finished the design, I ordered the boards, PcbWay sent them to me. Thank you, PcbWay. They're also sponsoring this video. And the boards came out really nicely again. But these things are so cute. They really are small and they are designed specifically to adapt to the existing Bluetooth module boards, as you'll see in a moment. Now, this switch is going to be activated when the Magic Eye tube switches off, which is what happens when you select pickup on the piano keys. The idea is that if you're listening to the pickup input, you don't need the Magic Eye tube, which is normally used for tuning. So it's very handy, very useful for our purposes right now. Now I've got the very few components ready to build one of these boards, not much to it. And I'll also be showing you the 3D printed case that I made for this. I'll be sharing the 3D print files if you want to do that yourself as well. Before I populate the board, I want to show you what I meant by adapting this board to that one. You'll see that this board is practically complete. The only thing missing are the wires, the audio output, and the power in from 6.3 volts and the 0 volts, which is the chassis in this case. And what I've got here on this board is another set of connectors which says 6.3 volts, 0 volts, and HV. You don't have to use that board. You can bring power directly to here. But when you do use this particular board, you actually bring the power to there. And the HV is the B+ signal from the Magic Eye tube, which acts as the switch. And then how do you power this? Well, that's where these two come in, 6.3 volts AC and 0 volts. And the way this is designed is so that it fits on top here. If you can see that hole there? That goes straight through. And then these two go straight through to those two. So I'll be showing you how I fit these like that, not touching the capacitor, just raised a little bit. And it actually gets raised by the wires that go from there to the bottom. And so this board receives the power and passes the switched power down to the Bluetooth board. But let me build this and then I'll show you how to adapt this. And then I'll also show you what the schematic's all about. It's very simple and there are actually various ways of doing it. I've just chosen the simplest one. I promise you I won't make you sit through my soldering, but I just want to show you something here. Why would I use a surface mount capacitor here? The board is set up for normal through-hole capacitors, in fact through-hole everything, but I decided to use this surface mount capacitor because I wanted to decrease the height above the board. If you can imagine, this board is going to go on here, and I didn't want another big capacitor sticking up the top there. And I figured the best way to do that is use a surface mount. It's 100 microfarads, the voltage rating is fine. And the way to solder this is actually easier than I first imagined. You actually put it on there and you solder from the underside. You pour solder in there and it will flow onto those guys over there. So let me do that and come back to you. Now I suggest before you start soldering wires into there, you actually connect the audio cable first. I've used a mono microphone cable. Remember, this particular one is set up for mono, so I only need one signal line and the ground to the audio. So that's in place, which will now allow me to solder this on top, and I won't have a problem getting to those wires later. And the way I do that is I use this wire. This is about 0.8 millimeter silver-coated wire. You can use any wire. It's fairly stiff, so I'll cut a couple of pieces off and start by soldering them in there. Okay. Oh dear, went straight through. That's pretty well soldered. I'll just trim this. And now I will straighten these guys up. And this board then fits nicely on here. It's got the same spacing as the one below. See that? Now I can fix this side in one of two ways. I can either put a spacer between here and there and tighten it, or I've found that there's an easier way to do that. And that is to use one of these little rubber feet with its self-stick on one side, and I will just put this on that cap like that, and then I will place this horizontally on there and just solder those two, and this should be perfectly fine. I don't need to actually fix that end. I found that it's not necessary, so this should be good, and it won't allow this these contacts here to, or the leads on the bottom, to short to the bottom side to the cap at all. Okay, we're done. You see, it fits perfectly well. It's horizontal. That spacer there, or that little foot there, prevents the shorting to the cap, and it serves as a rest. I can get to those holes there to connect the power lines and the high voltage B+. And this is going to go off there, and I'll show you one that I've already finished, because of course I'm making a few of these to be ready for the next few projects. And here it is. I've got the power connected. I have to be careful with this. The ground has to be ground, chassis ground, so that's the blue. There's the 6.3 volts. There's my high voltage. This comes from the signal that goes to the B+ of the Magic Eye. There's my audio cable. Now these guys are going to go off and get soldered into the radio. But I did do something else, and that is I built an enclosure for this, which probably is overkill, but I wanted to do it anyway because I like the idea of keeping this thing quite unobtrusive. So when you look at the back of the radio, you're going to see a black box. Those two holes will be used to somehow fix it to the cabinet. And this whole thing is going to fit in here. There's little holes protruding there that fit into there. Let's see if I can do this on camera. There we go. And then these wires are just going to go through here, out there. Let me do that and then show you the result. It'll be easier. Okay, we're good. Those fit into these little protrusions there quite nicely. If you want to really seal it down, you take a soldering iron and just melt a bit of the top there. I don't think it's going to be necessary. This lid is clipped, so when we close it, this is all we see. Now that should be a lot less obtrusive inside the radio cabinet than if the boards were showing. And now it's just a question of connecting it to the radio. But I'm going to do it on that guy on the underside, still temporary because I'm still working on the cabinet. And so all I want to do is to show you where I connect it. Obviously that's exactly where I will connect it when this is in the cabinet, but the actual position, whether it's on the left or the right, that'll be determined by the exact layout in the cabinet of the chassis itself. Right, so here's our schematic. And we have to realize first what this is going to do. This is going to produce one of two conditions. The one condition is where we want the Bluetooth board to have power. So the 6.3 volts will be there and the 0 volts will be there. And the other condition is we want the Bluetooth board to not receive power. And the option that I've chosen here is to leave the 6.3 directly connected and cut the ground line. You see that going through the relay. This is going to get cut in the second state where the board is off. And the board will be off when we have radio selected, right? Now, why have I chosen this? I could have opted to use this relay. It's a double pole, double throw to switch on and off both the positive and the, or rather both the 6.3 and the 0 volts. I could have used it to switch on and off the 6.3. Probably would have been a better idea, come to think of it. But I opted to cut the ground line because that's what I've been doing when I've been using switches to switch on the Bluetooth module on and off. I made various attempts at using these reed switches and lever switches and all sorts of stuff. And the way that worked was much easier to cut the ground line. And I decided to keep the same concept here. So I'm cutting the ground line. That's the option I've made. That's the one I'm sticking to. As I said, you can use it. You can redraw this and make the relay switch on and off the 6.3 volts. You can make them switch both. It's your choice. This was mine. And the other thing to point out is this relay, the TQ2 9 volts, I originally used, and in the board that I've just built, I've used a TQ2 12 volts. In retrospect, I believe that 9 volts would probably be more appropriate because this thing is being powered by the voltage over here. And the voltage over here is 6.3 volts, half-wave rectified, sort of smoothed. This capacitor is not that big. It's smoothed, and it produces around 9 volts. So this being a 12-volt relay, it does work. It works perfectly well. The new relays I'm ordering are going to be 9 volts. I've still got a few 12 volts, so I'll be using them for now. The other thing to notice is that this here, you can connect it to various places. In the past, what I've normally done is I've connected the 6.3 and 0 to the dial lamp, one of the dial lamps. Very easy to see the 0 volts and the 6.3. It's worked very well. The HV is a new line that I'm getting, and this one comes from the B+ of the Magic Eye, which means that these three can actually all come from the back of the socket of the Magic Eye, because we have the B+ right there, we have the 0 and the 6.3, which is the heater wires. So if you do want to, you can connect this directly to the back of the socket of the Magic Eye. It's your choice. I'm going to be putting it somewhere else. I'll show you where, but it's your choice. Now, in the first instance, what we have is this. We have the phono selected. Phono selected means that the high voltage is off. The Magic Eye is off, so we have no voltage over here. And if we draw the voltages in, we have something like that. We've got 6.3 coming in, which goes straight through. We've got 6.3 that gets half-wave rectified, and it's ready to activate or energize the relay. The ground comes down here and goes across there. It's connected to the emitter of the transistor, but there's no way for it to get through to there because there's no high voltage, so this transistor is switched off. And so the ground goes through there, goes there. The relay has a normally closed connection, which is between 3 and 2. So it goes from there to there, up there, and it's out. So in this situation, what we have is we've got Bluetooth on. Phono selected, Bluetooth on, right? In the other one, we have long wave, medium wave, short wave, or FM selected. And in this case, there is high voltage because we have the Magic Eye switched on, so B+ is over here. So these are the voltages. 6.3 still going through, 6.3 still producing the 9 volts over here to activate the relay. But now we've got high voltage, and the high voltage comes down here through this very, very big resistor, and it produces just enough current over here to switch this transistor on, which connects the ground or the negative rail of the relay coil to ground. So this relay switches on, and what that means is that the contacts in here flip over. And so we now have our ground going nowhere. So that means that our out has no ground, which means that our Bluetooth is off. It's as simple as that. Now, what else can I say about this? Well, let's look at the transistor. The reason I use this transistor, MPSA42, this thing's got a very high emitter collector voltage. I think it's about 300 volts. And originally I was trying to switch the relay on directly from the HV line. So I started using that and sort of just stayed in, and I ended up using the same transistor. You can use just about any NPN transistor here. I've actually experimented with the 2N3904, and it works perfectly well because this transistor is just switching on a 9-volt relay. This diode prevents damage from the inductive load switching off in the relay, so it won't damage the transistor, although this particular one probably wouldn't be damaged anyway. The point is, this transistor is working with a low voltage, and it's passing probably about 15 milliamps of current from this 6.3 volt rectified supply. So it's no big deal as far as current's concerned. The base is being driven from a high voltage, but there's a very big resistor. So all this is allowing through is, if that's 225 volts over there, call that 0.7 or 0 really. So 225 divided by 1 meg is about 0.2 milliamps or something, less than that. So this is not really going to be strained at all. As I said, I've experimented with the 2N3904 and it works perfectly well. What you've got to be careful about is if you're going to use the PCB that I've designed, you've got to make sure this is emitter base collector, the pinouts. Or if you don't, then you've got to make sure that you connect it properly on the board, but I'll show you the board in a second. So just a jelly bean type transistor will work perfectly well. 1N4007 diodes, again, no problem. Now this capacitor is interesting because, as I mentioned, I used a surface mount capacitor because I wanted to make the size smaller, but you can use any cap. Anything above 100 microfarads is fine. I used 100, works perfectly well. The other thing is this ground. This is really the same ground, but I created this as ground 3 because I wanted a ground plane on the PCB, and I wanted this ground plane to look different or separate from the ground plane of the main board. That was just for convenience. So this is really it. This is all it is. There's not much to it. I did think of creating a footprint for the SMD version of the capacitor, but then I realized it would be more useful to have a normal footprint, and I could use an SMD cap, which is what I did in the example that I've just soldered up, or I could use a standard through-hole cap. It's up to you. But again, the size of this is done so that this hole coincides precisely with the hole on the board below, and these two coincide precisely with the two holes on the board below as well, as you have seen. And that is our PCB. I did mark collector base emitter on here, so if you use a different transistor, make sure that these pins are the same, or that you flip it around, or whatever you need to do to make sure that it's collector base emitter. If you don't use the same transistor I do. And that's it. That's our design. I've wired this into the radio in the manner that I think is most logical for this particular setup. I've decided that I'm going to have the enclosure on the left end of the chassis as we're looking at it from the front. It's the right end as you look at it from the back. And here we have the enclosure. Everything fits nicely in there. Those studs there can be bent down or melted down if you want with a soldering iron. It would just ensure that this thing stays perfectly solid in there. I don't think it's necessary because this enclosure's got a lid and it's insulated, it's plastic, so it's not an issue. Now I'm going to make these files, the STL files, the print files, available. If you want to download them and print them yourself, link will be down in the description. So yeah, that's it. It's pretty big. It's actually bigger than it should be because most of this space is not used, but I had to make it tall enough to accept that little switch. And it clicks in place, and we've got our enclosure fully insulated, so if this touches something, it's not an issue. It goes off to the side for now, and we see the wires coming in from the side. The first wires that get soldered in are the signal lines, the actual audio out from the module. We've got ground there, and we've got the signal to the phono input. I prefer to solder it in instead of using jacks because I don't want to mistake the signal and ground lines, so that stays there. The line then goes on, and I've soldered the power line to the 6.3 volts out from the transformer, the heater winding. I showed you in the previous one, this is where this particular one is. You could do this anywhere. As I mentioned, you can do this to a dial lamp, you can do it to the back of the actual Magic Eye tube if it's more convenient for you. That's a little bit more messy and probably more difficult to reverse the whole process. I prefer this way. I leave this fairly loose because the idea is this is going to be at the bottom of the cabinet. When this is sitting upright, this is at the bottom of the cabinet. Leave it away from everything. It's a good idea. So we've got our 6.3 and 0 volts. And then here we've got the high voltage. As I mentioned before, I found the position of the switch that switches the B+ to the Magic Eye. So I've taken that from there. Again, as I've mentioned, you can take this directly from the back of the Magic Eye. But this is nice and neat. It stays out of the way. And the magic of this is that you can undo everything. You can literally just clip everything, and you reverse the whole procedure by clipping 1, 2, 3, 4, 5 wires. That's it. So our system is ready for testing, and there's not much to it except that I'll show you how it switches on and off. Basically confirm what I've already shown in the previous video. Here we go. I've got it on FM. Magic Eye's on. If I tune away from this, there is no buzz at all. If I put it on shortwave, no buzz at all. Same with medium wave. But if I put it on FM, I want to hear the difference in volume. So now I'm going to press pick up. Now I'll just get this old iPhone, activate Bluetooth. There it is there. I paired it previously. Just switch it on, and I hear the tone telling me that it's already found it. Now I'm going to put some royalty-free music, and that's it. FM. And of course it loses it, but it'll find it again. And of course, the minute I push radio, you see that blinking? The minute I push radio, it's off. The power's off. So folks, that's it for now. That is the Magic Eye switch for the Bluetooth module. And I think, unless I find something going drastically wrong with this, I think I found my long-term solution, repeatable solution for adding Bluetooth to these radios. Just about all the ones I do have Magic Eye, and they all switch off the Magic Eye when you select pickup. So we're good. And if you want to get yourself boards like these, I'll put the link down in the description, both to the Bluetooth module board and also to the switchboard from which you can get from the PcbWay share site. So if you want to produce your own, go right ahead. I've got no problem with that. Once again, thanks for watching, and I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Thanks for watching. Bye for now, and most of all, stay safe.